Okay, guys, so far this semester we've looked at triangles extensively, and then in the last chapter we looked at quadrilaterals pretty extensively. Triangles and quadrilaterals each have a lot of unique special properties about them. Moving on, though, we're just going to kind of now generalize the rest of the polygon. So we're going to look at, all right, any polygon now. We're not going to spend a chapter on pentagons and then a chapter on hexagons. We're going to kind of lump it all together now, okay? To start, what we need to be able to do anything in any polygon, we have to be able to analyze their angle measures. So we are going to start first by looking at angle measures in any polygon. All right, so we want to be able to find the measures of interior and exterior angles of polygons. And we want to be able to use the measures of angles in polygons to solve real-life problems. All right, so the first thing that we want to look at is the sum of polygon angle measures. So let's just really quickly recap what we already know so far. We have looked at triangles which have how many sides? How many? Right. So we've looked at triangles pretty extensively, and what else have we looked at pretty extensively? Quadrilaterals with 4 sides, right? All right, so what we want to look at here are, for the number of sides, what is the sum of the angle measures? So for a triangle, what was the sum of the angle measures in any triangle? 180, right? How about for a quadrilateral? What did we add all the angles up to? 360. Now, if you had to take a guess, what do you think would be the number or the measure of angles in a 5-sided figure? 540. How did you get to 540? Added 180. That seems to be the pattern, right? Okay. So how much do you think there is in a 6-sided figure? 720. Okay. How'd you get there? Add another 180. Okay, now let me ask you this. Let's say that I went ... skipped over a ton, and I wanted to know what are the sum of angles in a 100-sided figure. Now, I heard somebody say 1800. I'm guessing that you took 100 times 180. Okay, but take a look up here. When you have 3 sides, did you take 3 times 180 to get 180? So it's not directly linked like that. Did you take 6 times 90 to get 270? You're definitely adding multiples of 180, right? Like each time you add a side, you're adding on another 180. That is definitely happening, right? The question is, when you're looking up here, how many sides did you have? 3, but how many multiples of 180 do you have? 1, right? So you have 3 sides to 1 multiple of 180, right? Okay, now let's kind of readjust as we go here. Thinking in terms of that, 360, rather than thinking of it as 360, how many multiples of 180 is 360? Okay, how many multiples of 360 was 540? Right, we did 3 180s at that point. So what do you think the next one is? 4 180s. What do you notice about how many multiples of 180 I'm doing in relation to the number of sides there are? What's that relationship? It's the number of sides down by 2, right? So what do you think you're going to do to find the number of, or the angle measure for 100? 98, right? You're going to subtract 2, and you're going to take 98 times that many multiples of 100. See what I'm saying? So what do you think your general formula is for any n-sided figure? What are you going to do? If you have n number of sides, how are you going to find the angle sum? You're going to take the number of sides Very good. You're going to take the number of sides minus 2. Whatever that is, you're going to multiply it by 180. That's your pattern, right? That's going to give you the total of the angle measures inside. So next slide is just a recap of what I just said. It's just giving the general gist. You don't really need to write all this out because you've already bulleted your notes with sum of polygon angle measures and you've already shown all of that work for it. Just circle that formula at the end so that you know that that's the end goal here. Okay? So let's take a look at an example of how we might use this. All right, so I'm given in this example a bunch of stuff for the angle measures in this polygon, and I want to find the value of x. So naturally, we're going to do what we've always done with a situation like this. We're going to add all of these angle measures up to what the sum should be. Now, in the past, if it was a triangle, we knew we were adding to 180. If it was a quadrilateral, we knew we were adding to 360, right? Now we have to kind of extend this and figure out what should it be added up to. Now a lot of you will probably just memorize the number of angles in a 5-sided figure and a 6-sided figure for the first couple, but if I start talking about an 18-sided figure, you're going to want to use that formula, right? Rather than adding 180 up however many times. So I'm going to make use of that formula here so that we can all see it. Again, a lot of you probably can already rattle off what that angle measure is going to be. But let's just see where it comes from using the formula on the last slide. So remember that to find the sum of the angle measures, we're going to take the number of sides, which is 5, subtract 2, and multiply it by 180. So that gives me 3 times 180, which is 540. Now a lot of you probably said, oh, well, 5 sides. I already know that a 4-sided figure has 360, so I can just add an additional 180. And that's fine if it's a small number of sides. But again, if I start giving you a large number of sides, you're going to have to kind of use this formula to find it a little quicker. All right, so I now know that all of my angles have to add up to 540. So now I can just go around the figure and create a string of adding these up equal to 540. So my equation will look like 3x, and if I start moving clockwise, I'll get plus 115, plus 105, plus 4x plus 5, plus 2x plus 1, and then that should equal, so I've added up all of the angles, so that should equal 540 degrees. All right. So at this point, we can combine all our x's. So if we move along here, I've got 3x's plus 4x's is 7x's plus another 2x's is 9x. Plus, and then let's add up all of our constants. So we get 115 plus 105 is 220 plus 5 is 225 plus 1 is 226, that still equals 540. So now we can subtract 226. What does that leave me with? Not 316, but 314. Good. And then let's round this to the nearest hundredth. What is 314 divided by 9 to the nearest hundredth? So I should use an approximate sign. So remember that an approximate sign means this isn't an exact answer, it's rounded. It's just a wavy equal sign. And what did you guys say it was? 34.8 repeating? Yeah. All right, so rather than rounding, we actually can make it exact then with just putting a bar over the top. So I'll change that to an exact equal sign. If that had been just a random old decimal, I would have rounded it to 100th. But it's easy enough to keep that exact. All right, are there any questions on that? Simple enough? All right, let's take a look at the next example. I'll give you guys a second to write this down, and then we will get going. Okay, so first of all, take a note of what kind of a figure you have, right? They're telling you you have a heptagon, which means how many angles do you have total? 7 angles, yep. A heptagon has 7 sides, 7 angles. Okay, so you already know that you're dealing with a 7-sided figure, and then it proceeds to tell you that 4 of these angles measure 160 degrees each, not total, but 160 degrees each. And then it tells you that you also have 2 right angles. So how many angles have we accounted for total? 6, which leaves us with 1, and that's the one that they're asking about, is what is this remaining angle that we don't know yet. So first things first, you need to know what all 7 of these angles need to add up to. What is your calculation to see what these angles add up to? What are you doing? And where are you getting 5?
7 minus 2.
Right, so 7 minus 2, the number of sides minus 2, times 180. So that's 5 times 180, which is, very good, 900. So I know that all 7 angles have to add up to 900. So what's the first thing that you can do to start adding these up? You can do 160 times 4, right? So rather than adding 164 times, we can simplify that by doing 4 times 160. What else do you know? 2 90-degree angles. Sorry, guys, that's my phone going off. I'll turn it off in a second. Plus x for the missing angle, right? That's our 7th angle. Right now we've had 4 angles plus 2 angles plus our 7th angle. That should add up to 900. All right? So why don't you guys work on calculating this all out, and then we'll see if we all agree on the answer. All right, so here's the calculations that you guys should have done in the last few minutes. You should have gotten that x is 80 degrees. Anyone have any questions on that? Okay, let's take a look at what comes next. All right, so we've looked at what do all of the interior angles add up and how do we use it, but now what we need to look at are the exterior angles. So let's really quickly recap on what makes an exterior angle. Basically, an exterior angle is if you take one of your sides, and only one, not both. If you take one of your sides and you extend it off of the polygon, the acute angle that's formed there is the exterior angle. And you can just go around clockwise and extend each side off around the figure and form exterior angles at every single angle in the polygon. So the next question is, what should all of these angles add up to? And the answer is, the exterior angles of any polygon, any convex polygon, is going to add to 360 degrees. That is constant no matter how many sides you have. So I could give you a 100-sided figure, and while that interior angle measure is going to be different, the exterior angles are still always going to add to 360 no matter how many sides you have, which is a nice property. It's less work, that means, right? You don't have to find what the sum is. You automatically know that exterior angles are going to add to 360. And we're going to make use of that in one of the later examples here. Okay, so let's take a look at this example. What you guys need to be aware of is that those are exterior angles and not interior. Can everyone see why? Yeah? Okay, so we're dealing with exterior angles, which means automatically, what do you know they add up to? 360, right? Does it matter that it's a quadrilateral? No, it does not. The fact that it's exterior angles is enough to say it's 360 no matter what. So if I want to find the value of y, what is going to be my equation setup? Okay, 2y plus 2y plus y, right? So I added up all 4 of the exterior angles, and I know that those should total 360 degrees. So if I add up all of those y's, you'll count 6 of them, 6 y's, equals 360. And then if you divide 360 by 6, you get that y is 60. Any questions on that? So make sure that you're watching in your examples whether you're given interior or exterior angles. You'll have different sums for each type. Yes, Bree?
So any figure, the exterior angle will always add to 360?
Yes. So for any, I could give you 1,000 sides, and if I draw the exterior angles, they'll add up to 360. Yep. All right. So the next thing that we're going to look at are regular polygons. I said n-gons here because I'm saying if you have n sides, right, that makes up a polygon. I'm not going to specify how many sides we have. And this is actually a pretty basic idea. So what do you know about a regular polygon? What does that mean to be a regular polygon? All sides are the same, and for this particular lesson, we're more concerned about all angles being the same, which you said. Yeah, so it's equilateral and equiangular. We're focusing on equiangular right now, right? So if you know how many angles, or what the angles add up to in a figure, and you know that every single angle is equal, how can you find what one individual angle is equal to? Divide it by the number of sides, or the number of angles, right? So that's basically all that you have to do here. This next slide, and you guys, let me really quickly, before you start jotting all this down, you don't have to write all this out. Just make a title that says regular n-gons, like underline or highlight the word regular, and then just write interior angle, exterior angle. And maybe write the word individual, so you might want to say individual interior angle and individual exterior angle, but you don't have to write out that whole sentence. As you're writing, just try and listen real quick. Notice that all we've done is we've taken how we would find the sum of a polygon, and we're just taking that and dividing it by the number of angles that there will be, because we know it's regular, so all of the angles should be the same. I can do an equal division like this, right? Same thing for exterior. I know that exterior angles are always going to add to 360. So if I divide it by the number of angles there are, that should tell me how much each measure equals, right? So just to reiterate, we divide by n only if I'm looking for an individual angle in a regular polygon. If I'm asking for the sum of the angles, then you're not dividing by n and you're just taking either the numerator of each one, depending on whether you're looking at interior or exterior. All right? So let's see how we can make use of this. Most basic type of example is I'll give you how many sides the figure is. I'll tell you it's regular and ask you for one individual interior angle and one individual exterior angle. Okay, so remember for these, your first step is going to be to find how much do all of the angles add up to, and then just divide that by how many angles there are. So for a 15-sided figure, how am I going to determine what all of the angles equal together? What's that computation going to be?
15 minus 2 times.
Very good. 15 minus 2 times 180, and then since I'm looking for one angle measure, I take whatever that is and I divide it by 15 angles, right? So that I can find what one of the 15 angles is. Make sure you do your computations in the correct order. So in other words, do parentheses first. 15 minus 2 is 13, and now you can just type out on your calculator 13 times 180 divided by 15. What do you get? 156 degrees. So that's how much one angle measure would be in a 15-gon. It is okay, by the way, to get decimals. So you're not always going to get equal angle measures, like even angle measures. If you get a decimal, that's okay. You might not have good, perfect angle measures. Okay? How about for the exterior angle? How am I going to determine what one exterior angle is? What do you know all exterior angles add up to? And then to find one of them in a 15-gon, I would divide by 15, right? And so what do you guys get? 24 degrees. Any questions on that? Okay? Last example. I'm going to give you guys a second to write down the problem, and then we'll hack through it in just a second. Okay, so you're being asked, is it possible to have a regular polygon with each angle, or with each angle having the given measure? And we're assuming, and this is something I haven't told you yet, but if I don't specify interior versus exterior, what do you think you should assume? Interior. Yeah, you would assume interior if I don't say specifically one way or the other. Okay? Exterior, if I want you to look at an exterior angle, that's when I will specifically say the word exterior. But if I leave off interior versus exterior, just assume interior. All right? So that 160 and 115, you're assuming that I'm meaning the interior angle measures. All right? So basically, what they're asking here is, can I have a polygon that has, a regular polygon that has this angle measure for all of the angles? And if I can have it, how many sides does the figure have? All right? So there's a few different ways you can handle this, but I'm going to show you guys what is computationally the easiest. You just have to remember the trick, and it's usually helpful just to draw a couple of the angles. So 160, that's almost 180, right? So if I were to draw a couple of these angles, it might look something like, whoops, I did not want it to do that. Give me 1 second. Okay, it might look something like this, right? And what I am saying is that each of these angle measures is 160 degrees. That's what I'm saying. And I'm asking, is it possible, could I build this thing up so that it's possible to have each of those be 160 degrees? All right. Now, for an interior angle sum, you would have to know how many sides you had to calculate what that angle sum should be, right? For exterior angles, do you have to know how many sides you have? No. What do all exterior angles add to, regardless of the number of sides? So wouldn't it be easier for us to work with exterior angles? It would, right? So what we'll do, and this is the trick, if you can remember to look at the exterior angles, it actually goes by pretty easily from there. What we're going to do is focus on one of the exterior angles, which we do just by extending one of the sides out past, right? Just one side. Now, notice that when you extend a side out past like that, this red line forms a linear pair, right? This is 160. What does this angle measure have to be to complete the line? 20 degrees, right? That's easy enough. And then you know that if I were to find any of those exterior angles, all of them would have to be 20 degrees, right? Around the outside. And what do all of those have to add up to? 360. So how can I figure out how many sides that would have to be? How many 20-degree angles go into 360? What do I do? What did you do to find that? 360 divided by what one of my exterior angle measures is. What does that give you? 18. So your answer is that yes, it's possible. And then they asked what kind, how many sides does it have? It has 18 sides, right? Any questions on that? So when would it not be possible? Like, what would have to happen in this calculation for you to say, oh, that's bad? What kind of a number would you have to get in order for it to be, like, not good? What? A decimal. Can you have a decimal? Can you have half of a side and make a polygon? No. So that's what would make this be not possible. That would be the thing that you would be looking for. Let's take a look at one more. It's the same set of steps, so you're still going to kind of draw a couple of angles that look like 115 degrees. Now 150 degrees is just a little bit past 90, right? So I'll draw a couple of those. A little bit bigger than 90. And then remember that I'm saying that if I have a 115 degree measure in these angles, but interior angles are harder to work with, so what do I have to do? Extend one of your sides off of that angle and figure out what that exterior angle is, because that will be easier to work with. So what is the linear pair with 115? 65. And then we take that 65 and we know we're dealing with exterior angles, so what's the last calculation? 360 divided by 65, because I want to know, can I get an even number of 65s to go into 360, because that's what would add up for the exterior angles. What do you guys get for 360 divided by 65? What is the decimal? 5. This is enough for me to say, though, you get a decimal, you can't have a decimal number of sides, right? So what you guys are going to say, and I am going to be asking you to explain why it's not possible. All right, so you're going to say, no, not possible, and then you're going to say, because, and exactly what you guys have been telling me, because we can't have a decimal number of sides. And specifically here, we would say we can't have 0.53 blah, blah, blah of a side. Are there any questions on those last problems? Something to point out, you guys, is that I gave you 2 interior angle measures here. If I give you the exterior angle, is it easier or harder? Less steps or more? Less, because you already have your exterior angle. You can just take 360 divided by the exterior, right? So that would actually be 1 less step if I already gave you the exterior. Here I made you do 1 more step to get to the exterior angle first. Cool? All right. Here is your 11.1 homework. In addition to this, since we still have not been doing very well on the repeated problems from past quests that I have identified as being your struggle areas, you are now getting additional homework until we can start getting these problems down. So I'm going to be giving you a worksheet that you also are going to have to do, so you can include, and it's called Things We Need to Know Worksheet. Whoa. If you guys can start figuring this out and performing better on them, I will stop giving you additional homework. Until then, I'm going to start giving you these problems until you can start figuring them out. All right, so I'm going to pass out that worksheet in a second. I'm going to run through a couple of the trickier problems with you guys, refresh your memory on how to do them, and then the rest of the worksheet will be your homework in addition to this 11.1 homework due for Friday.